Let's do these problems involving measured quantities, so we will need to use our significant figure rules. The first set of problems all involve addition, and in addition problems, we're limited by the part of our answer is limited by the part of the problem with the fewest decimal places. So we're going to use our calculator and do the first problem, 83.4 plus 12.2 plus 1.234 plus 6.12, and my answer on the calculator is 102.954 grams. Well, if we look for the numbers with the greatest uncertainty, that's going to wind up being the 10th place. And either the 83.4 or the 12.2 limit our answer. So that means our answer can only go to the 10th place. And so we're going to not truncate, which means just simply drop numbers, we're going to round. And so the 5 rounds the 9 to a 0, which will bump the 2 up to a 3. And so our answer is going to be 103.0 grams. So when you finish a problem, you need to make sure you've got the right units. We do grams. The right number of significant figures reflecting the uncertainty in the problem. And so in addition and subtraction, we can only go to the 10th place, so that's what we've done. And you need to stop and see if your answer makes sense. We're adding some numbers all slightly less than 100. That ought to get us close to 100. We got 103.0. If I'd come up with 1,003, then I ought to stop and redo things because maybe I've pushed a button wrong on my calculator. So check the ballpark correctness of the answer, this number of significant figures, and the units. Let's do the next problem, and actually the next 3 problems. They're all more or less the same number, but there's something a little bit different about each one, and I hope it drives home this notion about the position of uncertainty limiting our answer. We're going to add 80 plus 12.2 plus 1.36, and we get 93.56 grams. In this first example, once again, our number with the greatest absolute uncertainty, the one with the fewest decimal places, is both the 80.0 and the 12.2. That means our answer can only go out to the 10th place, and so 93.6 will be the answer that we come up with by rounding. Answer makes sense numerically, have the correct units, we're going to the 10th place. And so what the 80.0 is telling us, or the 12.2, is our uncertainty is plus or minus 0.1. We're in the 10th place. The next problem has the same numbers, except we've dropped the 0 after the decimal place. What this is trying to tell us is our answer has uncertainty in the ones place. It's at least plus or minus 1 in the ones place. So our answer can only go out to the ones place. If we put 80, 12.2, and 1.3 in our calculator, 1.36 in our calculator, we'll once again get 93.56. Now we're going to round to the ones place. And so the best and correct answer for this second problem is 94 grams. The last version of this problem, the uncertainty doesn't lie in the ones place because we don't see a decimal point. When you don't see a decimal point, zeros at the end of a number are not significant. So our last significant digit looking from left to right is actually in the tens place. So our uncertainty here is plus or minus 10. So our answer can only go out to the tens place. And so we go back to the original number that we had on the calculator, the 93.56, and that will round down to 90 with no decimal point. If you put a decimal point there, then you're saying it's plus or minus 1 is the uncertainty, but it's plus or minus 10, so the correct answer is simply 90. So we've got 3 different answers, based on what the uncertainty is, yet the calculator gives us the same answer for all of them. Measurements have an uncertainty associated with them, and significant figures are to reflect that uncertainty. Next, let's do some multiplication and division. In multiplication and division, the answer is limited by the part of the problem with the fewest significant figures. It's the part of the problem with the greatest relative uncertainty. And so let's do these next two problems. 478.2 grams times 0.12 centimeters squared. So I need to square that 0.12 as I put it in the calculator. Divided by 47.63 divided by 67.3. And that would give me 0.002148, looking at the digits coming off of my calculator. The units, grams cancel, centimeters become squared over second. So I've got my units, I've got a big number multiplied by a small number, divided by two big numbers, so I'll wind up with a fractional number, and 0.02 is certainly a fractional number less than 1. But I have to have the right number of significant figures. The number 478.2 has 4 sig figs, 0.12 has 2 sig figs, 47.63 has 4 sig figs, and 67.3 has 3 significant figures. So the 0.12 centimeters is my number, the part of the problem with the fewest number of significant figures. There are 2, so my answer can only have 2 sig figs. So I'm going to report my answer 0.0021 centimeters squared per second. Or if you prefer, you can write as 2.1 times 10 to the minus 3 centimeters squared per second. Either answer is acceptable. The last problem, multiplication division once again. 7.2 times 10 to the minus third, so I'm on it. In my calculator, I'm going to put 7.2 exponent, change sign 3, times 891, divided by 6.43 exponent 2, divided by 5.465, and that will give me 1. So my answer is 1.8256 times 10 to the minus 3 is what I'm reading off the calculator. I've got meters divided by meters squared, which will give me meters in the denominator. I've got grams in the numerator, and I've got seconds in the denominator. So my units are going to be grams over meters over second. I've got a small number times a big number divided by a big number divided by a big number. So this 10 to the minus 3 may well be a ballpark. My units are what they turn out to be, but I've got to have the right number of significant figures. In multiplication and division, the answer is limited by the part of the problem with the fewest significant figures. So if I look at that, I've got 2 sig figs and 7.2 times 10 to the minus 3. The exponent does not enter into the counting of significant figures. 8.91, I've got 3 sig figs. 6.43, I've got 3 sig figs. 5.465, I've got 4 sig figs. So my answer is limited to 2 sig figs. So 1.8256 is going to round to 1.8 times 10 to the minus 3 grams meter over meter seconds. If you have questions, please look at your book, email me, or chat with me. Thanks so much.